Okay, this is number 33 on page 272, and there's no way around this. This is just a messy, messy problem. So anyway, we might as well just dig in. We've got cubic roots here in the numerator and in the denominator. I'm not going to rationalize this till the end. I'm going to try and work on that numerator a little bit, although I guess it really doesn't matter. Well, anyway, let's simplify this term here if I can. So I'll have the cubic root of 18 because there's no perfect cubes inside of 18, and then this is going to be 3 times the cubic root of 54. 54 is, if I break that down into threes here, I've got, that's 9 times 6, so 6, which is 2 times 3, times 9, which is 3 times 3. So I can see there in the numerator that there I have a 3 cubed, so a 3 will come out and a cubic root of 2 will stay in. So I'm just working on the numerator first. So let's say the numerator is going to be the cubic root of 18 plus this 3 now is going to multiply by that 3, so 9 times the cubic root of 2. And that's all over the cubic root of 3. Now there's no cubes again in the 18 that can be taken out, so I'm just going to leave it as 18 for now. We'll break it apart later. So I guess now, given that I can't combine these in any way in the numerator, I'm going to go ahead and start to rationalize the denominator. So I'm going to multiply it by 1, but I have to determine what my goal is. My goal is going to be to get a cubic root of 27 in the denominator, which is 27 is 3 to the third. This is a 3 to the 1. So my missing factor here is the cubic root of 9, which is a 3 squared. So I'm going to be multiplying by 1 in the form of cubic root of 9 over cubic root of 9. So here's a 1. And when I get this then, in my denominator, I should have a 3. So anyway, in the numerator I have to distribute that. So I'm going to actually take it down a line again here. So cubic root of 9 times cubic root of 18 is 3 times the cubic root of. So I'm going to start taking this down to prime. So this is 2 times 9, 18. So 2 times 3 times 3. And this 9 is 3 times 3. Okay, plus 9 times the cubic root of, and I have 2 times 3 times 3. So there's no cubes in there. But in the denominator now, I'll be all over a rational 3. So I multiplied the cubic root of 9 by cubic root of 18 here, and then I multiplied cubic root of 9 by 9 cubic root of 2 right here. So let's see what comes out. In the numerator here I have 3 will come out. Okay, so a 3 will come out and move to the front, and that 6 will stay in, and then this whole 18 will stay in. So in the numerator I'll have a 3 times the cubic root of 6, which is my 2 times 3, plus 9 times the cubic root of, that's just 18, all over 3. So I do have a common factor of 3 in both the terms in the numerator. So I'm just going to, for ease, I'm going to just factor that out. So if I factor out the 3 out of both of those terms, I'll have cubic root of 6 plus 3 cubic root of 18 over this 3 in the denominator. So those will cancel, and I'll be left with my final answer, which is just the cubic root of 6 plus 3 times the cubic root of 18. And that's the final simplified answer right there. As promised, this was a messy, messy problem, and there's other ways you could do it, other orders you could do this in, but one way or the other, you kind of have to crank through a lot of steps. And that's it.